Welcome to IMAGINIT's Elevate event. This recording is based around floor flatness done quickly using LiDAR. During the course of this video, we'll discuss the entire process of how to obtain floor flatness analysis, beginning with data collection, which has us using any number of devices to collect point cloud data. Once the data is collected, we can process the individual scans into one large point cloud by using a processing software such as Register 360. The data can be cleaned or adjusted and then used in another software to perform different types of analysis. This analysis might be visual or taken and published into a report. Data collection can be done by using any number of devices. Tape measure, cell phone. Yes, believe it or not, there is a LiDAR scanner in the iPhone now. For purposes of this demonstration, I'm going to talk about HDS laser scanners and handheld imaging scanners. Beginning with the BLK360, which can scan up to 360,000 points per second and complete a full dome scan in about 3 minutes. Using this scanner, we can easily get enough data to do a floor analysis. Then there's the RTC360, which collects up to 2 million points per second and completes a full dome scan in less than 2 minutes. This scanner is also capable of completing a full registration with very little user input. If we require a scanner that is capable of collecting data at larger distances and tighter tolerances than the other two already mentioned, there is the P-series scanner. All of these scanners are a fantastic choice to get the data needed for floor flatness. However, sometimes even the fastest of these scanners just take too long for some project requirements. That's why there's a scanner like the BLK2Go. This handheld scanner scans as the user walks the site at a slow pace and collects points and images. While it is not as accurate as the others I mentioned, it is a much faster solution. After creating several individual scans, the data needs to be stitched together or registered. As we collect scans, they register to another scan until the project is completed. Once completed, the data can be cleaned up if you desire, but if we are using one of the scanners I mentioned earlier, we often don't need to spend a lot of time doing that to do a floor analysis. The data can then be published to a variety of different formats. The Leica LGS file not only offers the option of comparing the point cloud with 3D model data, but it also adds file compression. The compression results in smaller files that allow more efficient workflow than using the data in another software package. Register 360 provides the ability to publish the point cloud and then attach the data directly to CloudWorx for Autocad or CloudWorx for Revit. This means there's no need for an extra file. Soon, Leica will be offering a new software that has more capability than we can mention here. The offering will be named Cyclone Enterprise. We also have the option to export to a variety of formats so that the data can be taken to a software that doesn't accept the LGS file. I'm sure many of you have heard of Autodesk's point cloud software known as Recap. With Register 360 and a Publisher Pro license, we can publish our data directly to an RCP file. We don't need to go to an intermediate file format. We can then publish our data using a limit box. We can publish our data using a limit box in Register 360. The advantage of this is being able to select only the area we would like to take a look at in the analysis software. Of course, with advantages, there are almost always disadvantages. The disadvantage to publishing by a limit box is if you later deem that there's need to see more data, you will have to republish your point cloud to that file format. To perform analysis in the office, we can use one of the following software packages. To begin, we can use CloudWorx for Revit or CloudWorx for Autocad. We can use Rithm powered by JetStream in the TrueView application. And then there's Cyclone 3DR. Each software has its own solution depending on what you're looking for. If we're looking to get something done on site, we can use a Windows-based tablet and Cyclone 3DR Touch, which has its own interface for Cyclone 3DR so it can easily be used with a touchscreen. Rithm with TrueView can also be used while on site without processing the data from an RTC 360. Let's complete a few of these workflows using the software. Let's begin by starting in Autocad. As you can see here, I'm in Autodesk's Civil 3D 2021. CloudWorx for Autocad will work with any Autocad variant like Civil 3D. So in order to run a floor flatness report or get floor flatness information, I need to begin by going to CloudWorx and loading my point cloud. I'll choose Open LGS, find my LGS file, and set its coordinate system. Click OK, and my point cloud will load. With the point cloud loaded, I'm going to spin this up into 3D so we can see the entire point cloud. As you can see, I have way more information than I need to do a floor flatness. So I'm going to spin this into an elevation view where I'm going to then go to clipping and do a Z-axis slice. Once I spin back to the top view, we can see that just the floor exists here. Now, depending on the information you're looking for, you might decide that you want just a visual representation of a floor flatness heat map. If that's the case, you can come up to Orientation, change the origin, and pick on an area of the floor where you want to measure from. We can then go to Color Mapping, choose our color mapping settings, and set our color map by elevation. Come down and set the delta so that we have a small distance, and then set the direction so it's in the Z direction. Hit apply, and we can see that the floor is relatively flat and meets the criteria we specified. Only the data that sits a little bit above the floor, like piles of wires and furniture, might show with color. If you're looking for more of a true flatness report, we can accomplish this another way. We can go to the Tools menu, and under Floor Flatness, we can come in and select the area that we want to measure. I'll go ahead and choose a rectangle in this area here, and we can see we reported back with a heat map. Once again, we'll set an interval along our Z-axis, and if we'd like to see this information in a profile and cross-section format, we can place a template beginning from one side of the floor to the other, and then generate our report and click Save. as the command runs computing the floor flatness, it will finish and bring up a PDF of this report. As I scroll down through the report, we can see my floor passes the ASTM floor flatness. We see the profile which runs along the center of the floor, and then of course cross sections that run the width of the floor. Leica recently rebranded their JetStream viewer product as TrueView. TrueView is a product that has been around for a long time, but not as a separate viewer like it is now. It used to run as an add-in on Internet Explorer. While the TrueView viewer is a free piece of software, it has available add-ins that can be very useful in determining floor flatness. If we're going to determine floor flatness in the office, we can use it with an LGS file to allow for the analysis of an entire scan. Once the point cloud is loaded, we will use a limit box to control what is being displayed on the screen. In this case, I'm displaying the floor only. Starting Rithm powered by JetStream, I can do an ASTM floor flatness analysis. Selecting the floor flatness tool, I can select an area that I would like to analyze by clicking on the floor to create an enclosed polygon. Once I've created the polygon, I can click 2 points as a line I would like to display on the analysis. I'll begin my analysis, and as the analysis runs, we then get a grid showing us values above and below the 0 line. From here, we can then create a report. Once the report is created, our File Explorer icon will blink on our start bar. I can open the PDF report and review my results. Earlier we mentioned using TrueView in the office along with an LGS file. That data, of course, is data that's been processed and put through Register 360 to be published as an LGS file in a complete point cloud. Sometimes our workflows don't allow for the time for us to process that data, and we need information more quickly than we would by processing that data. Leica's come up with a solution for this using the TrueView software. Rather than us grabbing an LGS file, we can go and open, and using just the USB stick from our RTC 360 scanner, we can go and select the RTC 360 project file. We can then go and select an individual scan to pull from that project file. Once it completes, we see the individual scan in our point cloud data. Now, if it's the floor flatness that we're interested in, of course this could be hard to work with and see in and out. Well, there's a tool for that here in TrueView, which allows us to go ahead and create a limit box. Our limit box will allow us to pick only the data that we want to see and control how much of that data we're looking at. Once completed, I can accept my limit box and spin my data up so that I can take a look at it from the top down. Now, just like before, I can come and start Rithm powered by JetStream and do my floor flatness. And begin my analysis, and then ultimately create my report from that floor flatness. Once again, there's my floor flatness. So all of our important information that we might need out of a scan can actually be done in the field. The next method to determining the flatness of a floor is where we'll take a look at Cyclone 3DR. Cyclone 3DR is a newer offering by Leica Geosystems, but by no means is it a new software package. Some of you may know 3DR by its former name, 3D Reshaper. Cyclone 3DR has the capabilities to work with a lot of different file formats. For example, I will be working with the LGS file. It is important to note that while 3DR is perfectly capable of evaluating the flatness of a surface, it is not going to run a traditional ASTM flatness report. With that said, there are excellent tools to both visually and annotatively report the flatness of a surface. Here I'm going to begin by loading the LGS file. Since I've used an LGS file, I can take advantage of a clipping that I created from Register 360 and saved with that LGS file. Here I'm going to use a limit box that shows just my floor's surface. This can save me a lot of time by only working with the data that I want to see. It can also save me time in that I do not have to wait to convert the whole point cloud to 3DR. I can only convert the area of my interest. Now, I can select my point cloud and choose the Surface Flatness tool. I can set my tolerance and click OK. We can see the results, the green, red, and blue, where green stands for the data that fits in my allowable tolerance. The red stands for the data that is above my allowable tolerance, and the blue, of course, stands for data that is below my allowable tolerance. From here, we can then go on to create a report. We can choose to measure the floor flatness by placing some labels around our point cloud showing the areas of interest. Click OK, and of course we can select everything and we can take a look at our report. We're going to transition our workflows out into the field. As time goes on, we have the greater need to gather information more quickly. Cyclone 3DR Touch assists us in doing that. 3DR Touch is made for use on a touchscreen of, let's say, a Windows tablet, for example. For my example, I will be using a mouse and pointer. So I'm going to begin by selecting New, and in the new window here, I'm going to create a new BIM workflow, but in order to do this, I need to have a previously created file with my BIM data already stored in that file. So I'm going to go to my previously created file and start my new workflow. As you can see, I'm getting some BIM data here, and I can turn all of my BIM data on. I'm going to now take what would be scan data and bring that scan data in. And once again, 3DR allows for the import of many different file formats. In this case, I'm going to use an E57 file to import my scan data. As the data imports, the software recognizes that my point cloud data and my BIM data are not close to each other. At this point, it allows me to move my scan data or move my BIM data. I'm going to move my scan over to the BIM data, where I can now use tools, for those of you familiar with Field 360, that are similar to what's used in Field 360, where I can move my point cloud and rotate it as we kind of pull down here and then rotate into place. Now, as I do this, all I want to do here is get pretty close to where I believe they would go together. From there, I can switch my view to an elevation view, and if needed, adjust the elevation view. I'm going to go ahead and allow the software to create a best fit between the point cloud data and the BIM data. As you can see, my best fit succeeded, giving me very little error between the two pieces of information. From there, I'm going to next, and I want to get rid of any unwanted point cloud data that we kind of see here on the outskirts. So I'm going to pick a distance threshold and allow the software to get rid of that extra data. If we look closely, we can see the point cloud data still exists, and obviously so does the BIM model. As I pull this up into a 3D mode, I'm now going to go ahead and compare the BIM model to the scan data. I'm going to do it along the Z-axis and tell it to inspect. As you can see, the software has picked up some deviation from the floor to the point cloud data. As I next through my data, I have the option to pick any predefined gradients. Next through, where I can now go ahead and add some notes. We can see the deviation on some of this data. With my notes created, I can then next through customize a report and look at that report in a PDF. I'm then able to export my report and save that as a PDF. And then I can save my file when I finish. Thank you for attending this session today.